Good morning to everyone. Respected dignitaries, esteemed guest speaker, dear participants joining us today from across the globe. On behalf of ICAR Accredited School of Agricultural Sciences, Sri Guru Ram Rai University, Dehradun, and Just Agriculture, ISASTR, we warmly welcome you again on the third day of 7 days International Faculty Development Program on the theme Integrating Traditional Wisdom with Technological Innovations for Sustainable Agriculture. Now, today we are deeply honored to welcome Professor N. Manikanda Bhupati, and we are very delightful to have you sir today as a keynote speaker. Professor N. Manikanda Bhupati is professor at Department of Biotechnology at Tamil Nadu Agriculture University, Coimbatore, India. With over 25 years of academic and research experience, he has been dedicated to dissecting biotic and abiotic stress resistance in various crops at molecular level. His research has significantly contributed to genetic improvement of rice, cotton, and several other crops. His notable work, genetic mapping and marker-assisted selection, basic practice and benefits is widely acclaimed and recommended as a reference text worldwide. So let us welcome Professor Bhupati for his valuable words and knowledgeable lecture ahead. Sir, please.
Yeah, thank you, Dr. Hitendra. Good morning, all. Am I audible?
Yes, sir, you are audible.
Just let me share the slide. Just let me know whether you can see my full screen.
Yes, sir. We can.
Right. Great. Okay. Good morning, all. It's my pleasure to join with you all in this important faculty development program. Before begin well on my lecture or keynote address on this particular topic, let me just thank the organizer for giving me this opportunity and all the participants who have going to spend your valuable time, 1.5 hour time with me. So this is a topic that are relevant to this present situation. How we are going to link the traditional knowledge with biotechnological tools that promotes sustainable innovation as well as provided solution or benefits to the present situation. Before begin well, I would like to tell you or give you some small prelude. What we are today is or what connects us today with the ancient world, like 10 or 15 centuries ago, is the only point here now is the agriculture, right? So agriculture is the point of junction that connects the age-old practices as well as today's modern tools. And the age-old in the sense we develop several technologies or methodologies and strategies to cope up increased agricultural production or that avoiding all the climate vagaries and all based on our traditional wisdom. I mean, when to sow the seed or how to use the sunlight as well as the moonlight, when to use the moonlight, or how to store the water and then how to distribute it, those water, and then how to enrich the soil and so on. So these are all we know as traditional knowledge. But over the years, when we encounter issues like outbreaks of new pest and diseases or the problems of water scarcity or extreme hot condition under the unexpected climatic condition, all these things will lead to generate new kind of technologies or tools, and that's what we have learned so far. But now we are in a crossroad that we need to link both traditional knowledge as well as the modern technology. Especially what I am going to focus now is not any other drone technology or high-end supplementary irrigation technology and so on. What I am going to focus here is how we can integrate the biotechnological tool with the traditional knowledge, and then that promotes the sustainable innovation. So that is what I am going to cover in this. The main reason for my topic of today is the challenge that we going to face in the future. Past and present, we have, as I told you, we have enough idea or enough kind of knowledges to increase the productivity. Even it is projected that it can be sufficient to meet the growing population in 2050. But even though we need to duplicate almost the production, but the resources that available inputs that we are going to use it is to keep on declining. One such input is water, right? So we need to make a very smarter decision in such a way that we are producing a sustainable agriculture product. So for that, we have to use several technology. So this should not be focused only on one major crop. Like in South India, we focused on rice. For in North India, it should be wheat. So besides some of the other pulses, it should not be restrict. All our promotion or all our research and development should not be restricted only with these major crops, because our main diet is made up of so many agriculture crops, starting from small contributed by small portion by the onions, tomato, and several vegetables, and those major as well as minor vegetables and so on. So we need to besides the fruits also. So we need to do promotion in all these things. So this cannot be done just to working on only certain crops. So we need to have all these things. And the main reason for not focusing on other crops and we need to focus only on major crop is the funding. The funding is focused only on major crops. It is not diverted, or it is not at all considered for minor crops like greeny vegetables or curry leaves, which are very fenugreek seeds, which are nutrient dense. So my point here is we need to focus the biotechnological or all other our knowledge generation not only in the major crops but also in the other minor crops, right? Or minor crops in the sense, so I didn't mean that it is inferior when compared to the major crop, but the fund that are allotted and then the research focus that are focused are very low in these crops. So the question now is, how do we get improve these yield, the so far unattended or untapped crops in the future? So here comes the role of traditional knowledge. So traditional knowledge is the one which we use for the long period of time over several generations. So this will help us to improve the productivity based on our knowledge, skills, and practices that we have developed over several generations. So this has been already reported in several literatures. And the main problem now what we are facing is in the name of technology, they hijack or they will just use these ideas or skills or practices and then make it as a new patent or copyright and so on. So what we need is we need to identify such traditional knowledges and then avoid the biopiracy that are arise from these traditional knowledges. So the biopiracy in the sense any unlawful or unethical usage of the traditional knowledge without the permission or the compensation that are giving to the original persons who have developed that TK, that is traditional knowledge. So my point here is we need to avoid such threats that are almost avoid or just ignore the knowledge that are generated by the communities during their generation after generation, and safeguarding such knowledge generation after generation. So so in order to safeguard TK, that is traditional knowledge, and then avoid the biopiracy, there is a defensive mechanism that has been formulated, and that is called as TKDL, that is traditional knowledge digital library. So under the aegis of CSIR, so they have developed this library, a digital library, as a national documentation or database unit, by collaborating with all the state governments as well as union territories, and it has been maintained as a national database. The main function of this database is not only collect and make a database, it also transcribe those knowledges into major 5 international languages, including English, German, French, Spanish, and Japanese. The reason for focusing on these 5 major languages is, of course, now we can use the Google Translator to transfer anything, any language to whatever our desired one. This database was established in it started in 2004 and it is almost completed in 2014. So during that period, we very much focused only on these 5 language, because US and European patent offices are having major numbers of patents that are generated from our TK, that is traditional knowledges. So we want to make them understand the US as well as European patent office in such a way that these knowledge is already existed in our India. So they should have some prior yard scale to grant such patents. So actually, this database acts as a defensive mechanism in 2024 for these 2 major patent offices, EPO and ESO, European Patent Office, and USA Patent Office, United States of America Patent Office. So because of that, we have successfully prevented several thousands of patents that arose from merely based on the knowledge of our tradition that are available in India. So I will quote some few of the examples almost at the end of our presentation. And now my point is not related to the defense mechanism, because it is a decade-old story. Before 2014, we have almost completed all the TK and then deposited as a database. Now, my point here is, in this decade, what we are going to do from the defense impact of this TKDL, we need to shift it to the discovery impact. So this is the point I am going to focus on the rest of the few slides. Right. So we need to shift from its original role of protective or defensive against the biopiracy to generate or discover new kind of practices with the novel experimental procedures, so that we can not only protect it but also utilize it very ethically and for the sustainable growth. So this is the word or keyword or mantra that we used today to make the environment very safe, but at the same time we are getting or benefiting from these knowledges continuously. So without harming the environment, we harvest the benefits of the traditional knowledge. So that is what my main focus will be in this lecture. So again, how we are going to integrate with the modern biotech. As I told you in the very beginning, we are not going to focus on the other technology. I will just like the drone or modern irrigation technology or soil science or any other technology, just a crop improvement technology that are supplemented with the biotechnology, right? So biotechnology not only is improve the crops for several desirable traits, but biotech tools can also be used in several other areas like phytochemistry and drug discovery, nutraceuticals, and development of functional foods, and evolving new biopesticide, biofertilizers, and then this we already did. More recently, we have two more actively growing area, that is called synthetic biology, and then large scale data mining using the artificial intelligence tools. So all these things we can do wonders when you integrate these traditional knowledge that are already available. Say, for example, in our laboratory, we are focusing on functional foods, especially for the cancer patient. I mean, after post-cancer treatment, we need to avoid the resurgence of the cancer. So for that, we have to employ the functional foods. And in our Ayurvedic as well as Unani and other medicinal literature, we have enough numbers of plants that are having properties against the cancer growth and development. So we just identify those plants and then now develop new methods or experiments that supports our idea. That is, that these crops can be used as a cancer preventing food like turmeric, pepper, and so on. So the idea is now we want to use the traditional knowledge, whether it is in a farming practice or is a food crop that can be used to treat some of the dangerous disorders or diseases like cancer. And that knowledge, preserved knowledge from the digital documentation, we just obtain and get the permission from the CSIR to employ those knowledges and then use these modern biotechnological tools like the transcriptomics, proteomics, and other omic tools, and integrated with the AI-based analysis, because it cannot be done with the simple analysis. We need artificial intelligence to deal such a big data that we have generated, and the main focus here is eco-friendly processing. So we don't use any unwanted processing method or which are harmful to the environment. So we use the natural process. At the same time, we merge with the modern biotechnological solution. That is the ultimate aim. So this will, we hope sincerely hope that it will give us a very sustainable novel innovation that can improve the value as well as empower the rural people living in the resource limited environment. So that is the main idea of our core interface that merge the traditional knowledge, digital library databases, as well as the modern biotechnological tool. As I told you, the main point here is linking the data that are available in the TKDL. Say, for example, one example I have shown as a cancer preventing food. Similarly, we can look for the novel antimicrobials. As you are aware, every year we used to get evolving new kinds of viruses and bacterial diseases, especially in South India during this winter season. November, December, we used to get new kind of viral diseases that spread like anything. So we need to identify a novel microbial activity containing food material or plant phytochemicals. So that can be, the initial search can be done with the TKDL search. So this if you find any antimicrobial that has been claimed in the TKDL, so that need to be validated by just designing appropriate biotech screening method. Maybe I will explain in the next slide what are the screening methods that are available for that. So this will ultimately help us a validated TK, traditional knowledge, that can give you a sustainable product. Again, I would like to stress the point that the sustainability in the sense it is continuous production without harming the environment. So that is the basic underlying point in this process overview. And this integration can be again done with several new searchable platforms that are not available in the TKDL, like development of BioTK Connect, so which can ease our searching work in terms of identifying effective bioactive molecules. And all these things should be under a FAIR principle. That is, the BioTK, BioTK or whatever a searchable platform you are developing, it should be under a findable, accessible, interpretable, and reusable idea. So without which we cannot use this TKDL for its integration in the sustainable product development. So here comes what are the technology that are available in the biotechnological arena, and which will help us to accelerate the research and development. So because this is the most important. So as such, TK, traditional knowledge, if you wait for a decade or something, some more than a decade, then it will not be very much useful. So we need to identify or screen a novel compound without spending much time as well as cost in this process of identifying the novel compound using the R&D. So for that, there is a large numbers of modern technology under the biotechnological tools, and all have been classified as omics tools, like genomics, proteomics, transcriptomics, epigenomics, metabolomics, and whether at a single cell or a whole cell. So the point here is it will fasten the speed as well as the precision of identifying the correct technology. And the appropriate technology depends on what is your objective of your compound that you are intended to identify. Some of the compound need to be identified at the genetic level, so we need to employ the omics. Some of them has to be identified at their metabolome level. I mean, how they are identified, or how they are used, how they are going to interact with your target organism or disorder. So depending on that, so appropriate omics technology we have to things. And again, this will help us not only to identify, it is very easy to test their toxicity as well as the safety level, because using our TK, traditional knowledge, it takes a long-term data collection for safety, toxicity and efficacy. But now using this omics tool, we can do it very quickly, and then very easily we can done all these things within a short span of time. So that is the another advantage of using the omics tools. So the both the toxicity, safety, and efficacy information, as well as the target identification within a short period of time and the cost, can be done using the omics related tools. So again, the point is we are using only eco-friendly methods that used to identify, extract, and then large-scale production if it is required using this technology. So these 3 points is deal with biotechnological tool is the ethical and economical benefits that are obtained from this integration, right? So that is the main idea. So here besides, we have economic advantage, as I told you, and so that we can can develop or obtain benefits, economic benefits, not only from national but also from the global competitive product. So this is what we have noticed recently with the moringa products, right? So though moringa is not a common crop in rest of the world, India is the one which has to produce a huge volume of crops as well as generate income from this moringa based product. And because of that, we can also ensure very affordable and but at the same time better health solution using this traditional knowledge. So in short, these TKDL integration with biotechnological will help us to make or realize the ethical and economic benefits at the community or social capital level with all inclusive development with a shared value. So this is the point. We can integrate the biotechnological tools with the traditional knowledge. So these are the some of the examples how the integration of the biotechnological tool help us to regain the traditional knowledge and their biopiracy that are used or explored by the other companies, the other multinational companies. So the one such famous example is turmeric. So there is a US patent called 401504, which granted in 1995 for the use of turmeric wound healing, right? For wound healing. But this later it was identified by this TKDL CSIR. Of course, this is the first case study that initiated or that make the people realize that we need to protect our traditional knowledge, which has been used for a long period of time. So CSIR has filed a re-examination application to USPTO, United States of Patent Office, right? So they just re-examined and then they revoked that patent. So similarly, there is a European patent that claimed for neem biopesticide, which can be used as a fungicidal activity. So this is have been used for a long period of time. Neem, use of neem for fungicide and other bactericidal activity has been known in India for centuries. But it has been given without any consultation with India. It has been given as a patent, and it has been opposed by CSIR and other higher officials of India. And after 2005, it got returned back. That patent was revoked, right? So likewise, we have several other examples. If I tell them, it will be a very just redundant. You might read now from this table. And as of now, after 2014, there will be huge numbers of data that are available, which are validated as well as protected or by the government of India. Library, as I told you, these are all in the 5 different languages. So without consulting these TKDL databases, no patent is allowed in US as well as European countries. So such a systematic search is available now. So because of that, we are preventing the biopiracy from our traditional knowledges. Not only that, now we can also narrow down all our searches or all our new patents, just checking it whether such knowledge is already available in the TKDL, Traditional Knowledge Digital Library. So this helps us to safeguard our, not only safeguard our traditional knowledge, but also promotes novelty as well as innovative strategies in the future, that too in a sustainable manner. Though we have talked about so many advantages and as well as several new examples that sets identification of innovative novel compounds, still there is key challenges. One such major challenge is standardization, because some of the traditional knowledge are in their original language in which it has been developed. So we cannot make a convincing terminology to make it as a standardized international standard format, so that we still found some of the limitation in integrating such traditional knowledge in the global databases. So that is the one. So this is the area which there is a new scope for future endeavors. So we can focus on those terminology and then find a equivalent biotech terminology so that it can be integrated in the modern biotechnological tools. And another one is the amount of data that we preserve. So because of that growing evidences, the size of the data is also increasing. So this makes it difficult to search it very efficiently. So that is another or challenge that we found. So we need to find very effective searchable databases or searchable platform that can search the huge database that has been developed. The next one is, of course, when you have these two, the next obvious issue will be the what we will infer from these databases. So after integrating these things, especially the Bubcom data and so on, which is the largest known database maintained by the US. So how we are going to integrate this and get information on global biomedical and chemical databases. So that is another things. So all these things require very robust policy framework, which can be addressed only with the nationwide collaborative R&D in these four areas, right? So these are all interconnected. So only then we can achieve the novelty and innovative discovery in the using the traditional knowledges. So my bottom line of this presentation is we have enough numbers of traditional knowledges that can give you more and more searchable as well as researchable as well as valuable leads that can be linked with the modern biotechnological tools. So this will help us to innovate novel technology in a very fast as well as precise manner. So, but this require integrating this knowledge of tradition with the biotechnological tool require very strong collaborative national framework. So then only we can realize the full potential of the TK traditional knowledge, right? So for one such example has been now generated by the Department of Biotechnology, Government of India. So they have generated a national mission. Now they have floated several project call for under this mission, and it is collectively called as Bio E3, Economy, Environment, and yeah. So the Bio E3 focus on this national mission on integrating these traditional knowledge with the modern biotechnological tools. So I am sure such kind of innovation through traditional knowledge will help us to develop a circular as well as green bio industry, which is the basic bottom line or basic of the sustainability. And then we so that in this line, if we develop such project, then we will be position our India as a global leader in the bio innovation. So thank you for your attention, and if you have any doubt, you can raise it or just kindly note down my WhatsApp number or email ID so that you can message me, or if your questions are not answered in this session. That's all from me, Dr. Hitendra. Please.
Thank you, sir. Now I invite our Dean, School of Agriculture Sciences, for vote of thanks. Dr. Priyanka.
You have to unmute. Please unmute. No, you didn't unmute.
Sorry for a technical interruption. Thank you so much, sir.
Yeah, please.
On behalf of School of Agricultural Sciences, Ram Rai University, and Just Agriculture organizing team, we are very thankful for the enlightening and thought-provoking session we have just experienced. On behalf of the whole team, I would like to extend our heartfelt thanks to our esteemed keynote speaker, Dr. N. Manikanand Bhupati, for insightful presentation on integrating traditional knowledge, digital library, with biotechnology for sustainable innovation. Your talk beautifully highlighted how ancient wisdom and cutting edge science can come together to build a more sustainable and inclusive future with importance of advanced screening and validation technique. The way you connected the preservation of your traditional knowledge system with modern biotechnological application truly opened our eyes to the immense potential that lies in collaboration between heritage and innovation. You have reminded us that sustainability is not just about technology but also about respecting the knowledge based down through generations, knowledge that has stood the test of time. By integrating this wisdom into digital platform and scientific research, we can not only protect our traditional knowledge but also empower communities, drive innovation, and ensure equitable benefits for all. Once again, thank you, Dr. N. Manikananda Bhupati sir, for sharing your expertise and passion with us today. Your words have certainly inspired us to think more deeply about the role such each of us can play in bridging the gap between traditional and modern science. Thank you so much, sir, for sparing your time and enlightening us. Thank you so much.
Thank you, ma'am. It's my pleasure to join with you all.
Yes, sir.
Uh,
We will meet soon through in collaboration, or we will be in touch with you.
Sure,
I
sure.
request all the participants kindly sir Bhupati's mobile number if is there in text
Yeah,
box,
maybe,
and
maybe
be
I
connected
will
with for.
share it again. I will share that.
Okay, sir. Thank you, sir. And that's all for today's session. Thank you so much, all the audience for today's session, and we will meet in evenings for evening session by 5 p.m. again. Thank you so much, and have a nice day.
Right.
Thank you so
Maybe
much.
I can. Yeah. Maybe I can share for 10 seconds and then I will close it.
Okay, sir.
Yeah. Can you see my
Yes,
screen?
sir. It's visible.
Yeah. Okay.
It's 9842509611.
Yes. Yes,
Thank
ma'am.
you so
Thank
much,
you.
ma'am, for sharing your contact details. Um, we will be in touch soon, and we'll do some work together in collaboration also.
Sure.
Definitely.
Sure.
Thank you
Thank
so
you.
much.
Thank you all for your time. Bye bye.
Thank you so much, sir.
Thank you, sir. Thank you very much.
Okay. Thank you.